Assalamu alaikum. In today's lecture we have to solve simultaneous equations by matrix method. Earlier before we did solving equations by elimination method, by comparison method and some different methods. Now we are going to solve these equations by matrix method. So you can see we have two equations, equation number 1 and equation number 2, and both are straight line equations. Why they are straight line? Because the power of variables 1. So if power is 1, it's a straight line. So it means this equation will be a straight line on a graph. Second one also be a straight line on a graph. But actually what we are doing, we are trying to find the point of intersection of these two straight lines. But with now matrix, these two equations in matrix form. So first step is to transform the matrices, transform into matrix form. So we are going to transform it. How to transform them? Simple is to put a matrix notation, and in first column take coefficient of x. In this case the coefficient of x in both equation we have 3 and 5. So write in first column 3, 5 and leave some space for second column and write -4, -7. In first column coefficient of x, and in the second column we have coefficients of y. Now next is to write x and y in a matrix equals to 7 and 12. Now this is a method through which we can transform the equations into matrix form. It's just to take coefficients of x and y in a columns, and along with the second matrix equals to the things which are on the right hand side. So next is to denote these three matrices a special name, like we called it A, and we called it this x equals to y, where A is this matrix 3, 5, -4, -7. Capital X matrix is xy, and y matrix is 7 and 12. Now if you want to find the matrix X by solving simultaneous equations, means to find the value of x and y. So we need x and y, which is matrix X. It means we have to find matrix X. So for x, if you apply A inverse on both sides, you will get identity matrix here, and A inverse will come here, A inverse y. So in order to find a matrix X, you need A inverse and y. Y is already given, so you just need to find A inverse. Say it equation number 1. Now first find inverse of a matrix. We know that inverse is equal to adjoint of a matrix upon determinant of a matrix. Now for inverse of a matrix, first find the determinant. Now you can see if you multiply 3 with -7, you get -21 plus 20. So it's not a singular matrix. You can do it directly. Adjoint, for adjoint of a matrix, we are simply replacing the replace the elements in the first diagonal and change the sign in the second diagonal. So you can see we will, in place of 3, we will write -7, 3 will come here, and this one is +5, so will become -5, and this +4 upon determinant. For determinant, you multiply this diagonal. 3 into -7 is -21. Negative is of formula, and then 5 into -4 will become -20. So inverse would be -7, -5, 4, 3 upon -21 plus 20 is -1. So -1 divides the whole matrix. We will change the sign of each and every elements in the matrix. So this -7 will become +7, -4, +5, -3. This negative is divisible by each and every element, so we will divide them. It will change the sign of every element. So we got A inverse. Now time is to find the value of x. X equals to, from equation 1, you can see here from equation 1, A inverse, value of A inverse is 7. Is here, is written here 7, -4, 5, -3. So we write it here 7, -4, 5, -3 into value of y is 7 and 12. So we write 7 and 12 here. Now we have a multiplication of matrices. We know that two matrices can be multiplied if the order of this matrix is 2 by 2 and this matrix has order 2 by 1. If these two elements are same, like 2 and 2, two columns and we have 2 rows, so 2 columns and 2 rows, if they are same, then we can multiply these two matrices. So how to multiply them? First row will multiply with first column, first row, first column. So 7 multiplied by 7 is 49, and -4 into 12 is 48, and next is 5 into 7 is 35, and -3 multiplied by 12 is -36. So x equals to 1, -1. Now what is value of x? Value of x is x and y. So place x and y here. Now here two matrices are equal. So for equal matrices, according to definition, their order should be same. In this case we can see 2 into 1 is the order of this matrix, and 2 into 1 is the order of second matrix, so they are equal. So if two matrices are equal, their corresponding elements are equal. It means x should be equal to 1 and y should be equal to -1. So we solve this equation, simultaneous equation, and x1 y equals to -1 is the solution of given simultaneous equations. Can we check whether our answer is correct or not? We have a check method. Just in equation number 1, if you can see here, in equation number 1, if we'll put 3 into 1 minus 4 into -1, 3 into 1 is 3, and negative positive, so 4 plus 3 equals to 7. So it satisfies the equation. Same, these two values will satisfy the second equation as well. So hope you will understand how to solve simultaneous equations by matrix method, and please don't forget to subscribe my channel. Thank you very much.